So the following is either me saying something brilliant, going out on a limb, going out on a limb too far, or just pulling things out of my ass. Um, also, those options aren't necessarily mutually exclusive. So this is me from a video that I put out about 10 months ago, um, explaining my idea about consciousness. And the context here is that I'm talking about how the act of consciousness, the experience of consciousness, is what uh, virtual reality is modeled around. And so I'm just going to let this one play um, and talk a little bit more about it on the other side. When you put on a pair of virtual reality goggles, what is the entirety of the virtual reality world built around? Right? It's math, it's computer programming. You could look at those ones and zeros, you could look at that computer programming, and you could understand it abstractly, but you wouldn't truly get it if you didn't realize that all that computer programming is organized around the idea of a conscious one in the middle. It is the geometry of the inside of a sphere, which means that everything in a virtual reality setting, in the virtual reality program itself, in the math itself, is organized around an idea of organized wavefronts. Have to be organized because it's information. If they were disorganized, they couldn't carry information. Organized wavefronts converging on a conscious point at which that information is resolved and gains its meaning. So that's the idea. Consciousness is a point at which organized wavefronts converge. And I would say probably would then be that point itself. And this would, perhaps it would solve the binding problem because you have all this information now that has become this one point. I think it would share certain similarities to a black hole, meaning that beyond a certain point, the event horizon or whatever, mathematics itself would break down because the whole thing would skew to infinity, right? That's why, even if it's just a statistical anomaly that you never see it in nature, the perfection of that math to get all those circles to then all those waves to then perfectly resolve at one point would be, just infinitely unlikely. But here you have two of the problems of consciousness. One is you have the binding problem. You have all that information becoming bound into one thing. And you have the infinity problem where, the math would go to infinity. But that, and I've argued this in other videos, is what consciousness is. It's why Donald Hoffman's work is off and comes to the absurd conclusions that it does, because he's running models that assume that the thing to be explained, you or I, is a closed off finite system where you and I are not. We are constrained infinities. We are nested infinities. We are a lower order but still infinite being. And the reason why you know that you're infinite is because you have feelings. You have qualia. That's why everybody wants to get rid of qualia. Like, oh, it's this qualia stuff. Well, it's because you can't represent it in finite math. It's not substrate independent. qualia is only possible in an infinite substrate. This is where you have to then understand the innate meaning of Gödel's incompleteness theorems because math can't get you there. You have to understand because math can't get you there, it's infinite. You can't program feeling into a machine because in machine world, in machine language, in mathematics, meaning is an infinite regress because nothing can stand in as the final authority. The final authority is always one step away. That's Gödel's incompleteness theorem. It just goes off into infinity. So conscious beings are infinite, or at least have access to the infinite. Okay. And so to just touch upon what the binding problem is, and why it's so difficult. They talk about the hard problem of consciousness, and for me, when you're talking about consciousness, you're always talking about the hard problem of consciousness. Everything else is details. Um, but the hard problem of consciousness is just simply what it's like to be from the inside. This conscious experience that we have. And perhaps the hardest part of the hard problem of consciousness is the binding problem, though most people aren't aware of it. And so this here is a Radiohead video, House of Cards. And forgive me for the way I have it displayed. I just, don't like to put work into a video and then find out that I've infringed on some copyright. So this is a way around it. But you can see here that this is Tom York's face. And also, I just find interesting that maybe immediately it wouldn't be apparent to you that that's Tom York's face, but you get that in emotion. And it becomes more apparent who you're looking at. My apologies that, it's not at the exact spot in the video where I would like it. But so this is Tom York. And the way that they filmed this video, they filmed it with two or three cameras that weren't regular video cameras, had nothing to do with light. In this particular instance, what they're doing is they're using sort of like a LiDAR detector that's shooting bits of a laser at him. Those are those points that you're seeing that then come back to the sensor and make a map. Um, and so one way to think about the binding problem is that if you were to watch that video and you know who Tom York is, you'll know immediately that those bits are creating Tom York's face. But you're only able to do that because you're binding those bits together. And then also to use this as an analogy for what computers can't do, says computers are always binary. Without going too far down that rabbit hole, what I would argue is that from a computer's perspective, if there could ever be a computer's perspective, a computer could only deal with one of those bits at a time. It seems like it can deal with all those bits because it serves it up to us so quickly that then through that motion and through the whole gestalt that you're seeing there, we're able to bind that together into Tom York. But from the computer's perspective, where such a thing even possible, the only view it would have is one bit at a time because it doesn't have that binding power. It doesn't have the binding problem. And so we're able to bind all of that together. And so the binding problem goes, much deeper than that. Part of what I'm trying to do in this particular video is just to establish an appreciation for how vast the problem actually is. Because one of the things that bothers me in the whole field of consciousness studies is how quick people are to hand out consciousness to all and everything without appreciating, just how difficult uh, consciousness would be, just how much it resists our every efforts, not just to explain it, but to define it. And the binding problem is, a big, big part of that. And so it's not just that you can bind all of those bits into Tom York's face and then bind all of those bits with your memories of Tom York and your understanding of Tom York and whether you think Radiohead is one of the best bands ever or completely overrated. Um, so when you take in visual information, it comes through your eyes to your retina, optic nerve, to the back of the brain, and then it goes out to the rest of the brain, and it goes to at least like 20 different centers in the brain that handle things like size, shape, color, memory, motion, you know, all of it. And all of those regions in your brain are disparate and they've all been thoroughly mapped. And what no one's found is a place where all of those places then converge into one thing. Yet you're able to see Tom York's face, yet you're able to see my face, yet you're able to look all around you and see specific objects. Furthermore, if those objects are making a sound, you're able to bind that sound to that object. If that object has a smell, you're able to bind the smell to that object. And so one of the reasons why I think that consciousness is so intractable is because it ends up doing infinite things. And people are resistant to that idea. And most theoreticians in the field operate from an assumption that, yes, these are very large things that we're doing. We have billions of neurons in the brain, and apparently they have trillions upon trillions of ways that they can connect. Read somewhere once that the number of connections that the neurons in your brain can make are in order with the number of positively charged particles in the known universe. That's very great, but it's still a finite thing. It could be hard then to think that everything that the brain is doing is even beyond that. But that's what I'm arguing is the case because not only are we binding all this information together into one intelligible thing, but when you go and you look at what that intelligibility means, if you start really to penetrate into the depths of meaning itself, the edges of that meaning is an infinite regress, and you will never get to the edges of that meaning. This is why a few videos ago I made the bold claim that I'd proved free will. Well, the reason that I made that claim was that it occurred to me that day that a mistake that people like Robert Sapolsky and Sam Harris are making when they say that you know we don't have free will is that they're assuming that a choice is between two finite local data sets and a local finite data set is making that choice. But if you were to really think deeply about the choices that you're posed with, especially on a high conscious level, in the video I say, just choosing between Coke and Pepsi. Well, Coke and Pepsi are brands. And what is a brand? A brand's a completely ephemeral thing, and it's composed of all these other ephemeral things. And if you try to get down to the bottom of the meaning of either Coke or Pepsi, separate from just its chemical structure in some container in front of you, what you'll find is that that's an infinite regress, and that meaning keeps giving meaning on and on and on, and you'll never get to the end of it. So if you're choosing between two infinities, the only thing that could handle that within you is the only thing that could possibly be infinite within you. Your brain is not infinite. Again, it has an incredible amount of ways that it can be ordered, but you would get to the end of the various ways that you're able to shuffle that deck. But the things that it's dealing with, qualia in and of themselves, are substrate infinite. They have no end, they're bottomless. And so the only thing that could make a choice between those things is the only thing that could possibly be infinite within you or have access to the infinite, and that's your consciousness. So it helps me to just sort of set the stage for where the various thoughts come from. And I've been listening to a lot of Roger Penrose and Stuart Hameroff and their idea of consciousness, OR, orchestrated objective reduction. I think the objective is where they're making the mistake there, um, but I really like um, the two of them and a lot of what they have to say. One, because Roger Penrose is Roger Penrose, but two, he's extraordinarily intellectually honest. And so he's willing to look at Gödel's incompleteness theorems and understand that Gödel's incompleteness theorems point towards an infinite regress. And so something uncomputable has to stand outside of that infinite regress to see it. You can't, obviously nobody can um, explicate, for lack of a better word, objectify, make empirical uh, infinity, but we can see, no, that's an infinite regress. It goes back and forth, goes back and forth. There's a famous Gödel sentence. He says, "This sentence is a lie." Well, if the sentence is telling the truth, then um, it's a lie. But if the sentence is lying, then it's telling the truth. But if it's telling the truth, it can only be telling the truth if it's lying. And so it goes back and forth and back and forth. And that's not just toggling between two static invariant states. Those states are more like a Ouroboros, the feathered serpent that's swallowing its tail that the Aztecs, the Mayans, forgive me, it's one or the other or both, had this idea of infinity, of this serpent eating its tail. And so we're able to see infinities without ever getting to the end of an infinity. So something uncomputable has to stand outside of that. So I really like that it's Roger Penrose, but that he's penetrating deeply the mysteries of Gödel's incompleteness theorems. And so this leads him to the non-computability of consciousness. And then um, Stuart Hameroff has a really powerful point that as an anesthesiologist, he turns consciousness on and off. Now, what I would argue to him is that you turn consciousness on and off in the body. And so I would be this very unfashionable thing that they roughly call the libertarian substance dualist. I think the body is host to consciousness. I don't think that the body creates consciousness, but that's, anathema to what people believe science is. I would take issue with that. But so I was at the park and I'd been listening to mostly Stuart Hameroff and Penrose, um, for several days, just kicking around their ideas. And I just found them finally getting to a dead end. Find that almost everybody finally defaults to some sort of um, reductionist it from bit approach to consciousness that we know doesn't work, because if it did, somebody would have figured it out by now. It would have been straightforward, if very complex. And so I went to a place on YouTube where the noise is just so much less. So if you were to put consciousness into the search bar into YouTube, you will see no end of content around that, hours and hours of the brightest minds on the biggest podcasts. And again, theoreticians just doling out consciousness all in sundry and having not even a really good definition of that. But if you put the binding problem into the search bar, what you will find is orders of magnitude smaller amount of content around the binding problem. And I just wanted to go there because I just sort of wanted to get away from the hype and the noise and revisit that. There's one really good um, lecture. It's about an hour long. I'll link it in the description. That's a cognitive theoretician who specializes in the binding problem, trying to convince a room full of computer programmers that they'll never get there from, ones and zeros. At the end of it, he's sort of laughing them off derisively as they, throw up the usual arguments. He's just like, you don't even know what you're dealing with. And so I went back there, and there was a new video under the binding problem that I hadn't seen. Um, and I thought, based on the clip that I just shared with you, that, hey, maybe I had hit upon something like truth. And so this is a physicist who is giving a talk at the Science of Consciousness conference that the University of Arizona puts on every 2 years. His name is Michael Elliott. And what does he have here? Black holes and the binding problem. And so I was, feeling vindicated. I mean, I call my channel the outsider's voice. I'm coming from the outside. I'm a layperson. I'm a poet. I'm a personal philosopher. I just like to kick these things around in my mind. And here I had made this connection between the geometry of a black hole, the mathematics of a black hole, and the binding problem. And then here's somebody who can step in and do the science and do the math that's arguing the exact same thing. Um, and so what he's talking about here is this, apparently it's a huge thing in physics. It's the ADS CFT correspondence. That stands for anti-de Sitter conformal field theory correspondence. And apparently it's the biggest thing in physics in the last 20 years. I'm going to share a little bit from Leonard Susskind. And he talks about, you want to know how big the the ADS CFT correspondence it is the most cited physics paper in history. It has like 15,000 citations. And so, it's head and shoulders above everybody else. And it's a mathematical model. Return to Michael Elliott here. So this is roughly the model. And if you follow anything, around physics, you may be aware that there's this problem unifying general relativity with quantum mechanics. The two should go together, but physicists and mathematicians can't get them to meet. And so this ADS CFT model is based around thinking about black holes. And what you have in the model is an infinite boundary. So you just accept that this boundary is set at an infinite distance and that it's two-dimensional, quantumly entangled information that, like a black hole, has an event horizon and has a singularity at the middle where all the mass is. The mass at the center is in communication with the information on the boundary by gravity. And so what he's made the connection on here is what I believe I was, we'll just say stumbling upon in my attempt at it, which is that you've got this information that's on the outside of a sphere. And if you were on the inside looking out, you've got all this information that's coming together in the center where the information is bound into one thing. And so he's arguing that this is the only model that we have that could solve the binding problem, that could solve taking all this individual information, that could solve taking all of these points and all this motion and all this sound and all this vibration and all this memory and all this context and all this culture, and in real time bind it into one thing. Part of what I would like to, get across in this video is understanding how incredibly complex the information is at this boundary, um, and how that amount of computation, he talks about uh, P versus NP. So P versus NP is a problem in computer science where you have problems that can be solved in polynomial time and you have problems that are non-polynomial that can't be solved in polynomial time because as you bring in variables, the problem becomes exponentially difficult. So I'm just going to play a quick bit here in the hopes that this little bit explains just how difficult that is, so that we can begin to get an appreciation just for what our consciousness is doing for us moment to moment.
If someone gives you a completed hard puzzle, like a large Sudoku or crossword, the answers can be verified much faster than it can be solved in the first place. It's the same for a computer. The reason these types of NP problems can be more difficult for a computer to solve is because, as far as we know, their complexity increases exponentially as their input increases. An exponential function has the variable in the exponent like 2 to the power of n. Here's an example of exponential versus polynomial growth for the same input. With these hard exponential NP problems, the increased complexity of large inputs can quickly exceed the limits of what a computer can compute in a reasonable amount of time.
And so when they're saying a reasonable amount of time, they're basically saying all time that we have available to us on Earth and all resources that we have available to us on Earth. And so the binding problem from a consciousness perspective is so great that all of the servers in all of the world, indeed, all the quantum computers in all the world, and this is what Michael Elliott is arguing in this video, would be woefully insufficient, wouldn't even be able to scratch the surface on being able to bind all that information into your conscious experience and play it out in real time. And so, starting from that, Michael calls this a gateway problem. What is the only thing that could solve that mathematical problem, that exponential growth? And the only thing that could solve that, this is his argument, would be this ADS CFT, which happens to be modeled on at least a theory of how black holes would work. So, you know, that's I would argue an interesting fact, a place to begin to appreciate the very thing that everybody's trying to explain. And there were two pieces to this that took me, 48 hours to really grok. But when I grokked them, when I understood them, it really opened up a new window on how to look at all this, at least for me. And that's, what I'm trying to share. And what he's saying is that the information at this boundary is so beyond what we could ever hope to compute ourselves. I'm going to play a piece from Leonard Susskind to really drive that home in a second. But what's happening in this model is that gravity itself is doing the heavy lifting. Gravity is in touch with everything. Gravity touches everything and everything obeys gravity. And so the way the model works is that gravity pulls that information down to the center, what's called the bulk, and creates the simplest description of that information as a three-dimensional model. So two-dimensional, quantumly entangled, two-dimensional information at an infinite boundary becomes a three-dimensional form through the power of gravity that is the simplest description of that information. And so the only thing that we know of that's possible to do those calculations is gravity itself. Now, just to, answer the obvious question, is he arguing that we are black holes? No, he is not arguing that we are black holes, but just shy of that, something in our brains, something in our bodies would have to be like a Bose-Einstein condensate. And so when you supercool helium down to just a few, 2 degrees Kelvin north of absolute zero, superfluid helium takes on this quantum state where the atoms stop behaving as individual atoms and start to behave as one bound, entangled quantum entity. And he entertains the notion that anything that is in that state has some measure of consciousness. The problem is that's 2 degrees, or somewhere between absolute zero and 2 degrees. Um, and so obviously nothing like that can exist in the body. The one hope is that there's something called a Froelich, hope I'm pronouncing that name correct, condensate, which is a scientist who postulated that it's possible to have a quantum system at warm temperatures provided enough throughput of energy into that quantum system. And so there's some hope for this Froelich condensate. Stuart Hameroff is also hopeful in that direction. But even that seems, you know, like a very small possibility, because think about how robust your conscious experience is and how fine and difficult a process of creating a condensate, a superfluid in your body would be, and to create that and have that have a constant identity over a lifetime. So again, if nothing else, just trying to paint the picture of how enormous the problem of consciousness in a body actually would be, because you would need something that could do this ADS CFT, and the only physical models that we have of that are either black holes, super fluid helium, which is at incredibly cold temperatures, and so obviously can't exist in the body, and Froelich condensate, which is, hypothetical, on the verge of theoretical. But still, if you were to think about your sphere of awareness and you were to take your sphere of conscious experience as the only thing, and that's not a ridiculous thing to do, because as many other people I've been listening to in the last, 2, 3 days have been saying, really your conscious experience is the only thing that you can be absolutely sure of. In other words, your conscious experience is what you have. You have direct access to that. That's the one thing that you know for sure. Everything else is, abstracted, is a conjecture within that. And so if you were just to look at your own, feel your own, hear your own conscious experience, it is something like a sphere with an infinite point at the center, which is you. And all of that information is coming together in that one place and is being bound together. And that's the binding problem. So I'm going to play this clip from Leonard Susskind. He's, one of the greatest living physicists and he works at Stanford. And just, if I can ask you to be patient and listen to this, it's going to play for a little while, but get your mind around just how complex the universe actually is, real or illusory. Get your mind around just how hard the hard problem is.
All of these things have been deeply influenced by the same kind of duality. What's at the middle of it, right at the center of it, is on the one hand general relativity, and on the other hand quantum information theory. I think it was this that Andre was referring to when he said that something was going on. And it seems to be something which I don't much like coming and selling things. But I have to say, I have a real sense of excitement that something bigger and better is happening in theoretical physics than I can remember for many years. So whether it will pan out or not, I don't know. Okay, oh boy, this is hard to see. All right, I can see it here. Let me start with an observation of Feynman's from 1980. I think it was about 1980. He asked himself, why is it so hard to solve quantum mechanical problems? What he meant by that is, why is it so hard to simulate them on a classical computer? And his answer, this is a quote, a direct quote, because Hilbert space is so damn big. Sounds like Feynman, it was Feynman. Let me give an example. There are many systems which can be described by bits. Bits are just bits of information like inside your computer. A state of such a system is typically described by a string of zeros and ones. There are physical systems like this. In fact, every physical system can probably be brought to a description like this. So a state of the system is just a string of zeros and ones. Supposing there are 1,000 bits. Well, if there are 1,000 bits, you can write down the configuration, just in binary digits. You can write them on about a page. Okay? So, not too bad. On the other hand, take the same systems, but think of them as quantum mechanical. Quantum mechanical qubits. Qubits are quantum mechanical bits. What you can do with qubits is you can superpose states, quantum mechanically superpose states. I assume you all know what that is. You can quantum mechanically superimpose the states, and you have to superimpose them with complex coefficients. How many quantum complex coefficients does it take? Well, there are 2 to the n configurations of these bits. So it takes 2 to the n complex numbers to describe the quantum mechanical analog of the bit string. 2 to the n complex numbers would be so large that if you had just 400 qubits, you could not fit the entire description of the state of that system into the entire known universe, even if you packed it at Planckian density with zeros and ones. Quantum states are typically exponentially complex in some sense. The term complexity has a technical meaning, but for our purposes, it just means hard to describe for now.
So when I push back against somebody like Donald Hoffman, this is what I'm talking about. The problems that need solving are essentially infinite. I mean, to describe the quantum freedom, sure, I'm way beyond my depth, but to describe the same state, to describe a classical state and just to describe it in its quantum state, the amount of information is so big that if you were to pack the entire universe at Planckian lengths with ones and zeros, the whole universe wouldn't be big enough. And the Planck scale is the absolute smallest scale that we can conceive of. And so this model of the ADS CFT is essentially a holographic model. It's two-dimensional information that gravity is interacting with and is creating a three-dimensional structure at the center. When somebody like Hoffman says that we look around us and nothing we see is real, the reason he's saying that is because that quantum reality that gives rise to the classical reality is so large, so infinite. I mean, think about that. The entire universe, ones and zeros at the Planck length, and still you couldn't fit them inside the entire universe. If you're trying to give over the task of translating all of that information to a finite, isolated, closed system, there's no hope. And so that finite, closed, isolated system can only make up a heuristic, a series of heuristics to find what it needs to survive and then within the language of that series of heuristics, it can't hope to create anything that matches that reality. I keep arguing that, and I yet have anybody to interact with me in the comments section that actually at least gets what I'm trying to argue. But even that aside, our ability to bind all of that information into one representation requires the same thing, the same process that the universe relies on to create classical reality. So everything that you see, if this were the actual truth, the information is held on a horizon, on an infinitely far boundary. It's quantumly entangled. It's so large that you couldn't fit all the ones and zeros if they were at the Planck length in the known universe. And it's being translated into a three-dimensional hologram that we interact with as reality. But our own experience of that requires the same mathematics to bind all of that information together. And so I think Hoffman's theory is a non-starter from the beginning because he's dealing with finite local data sets, and everything that consciousness is doing requires infinity. And so what I would argue is that what we have here is something like a model for mental health. And it's something like a model for societal and cultural health, mental health in terms of a community, mental health in terms of you and I being able to relate to each other. Because the quantum information of the world is so great, it's beyond what we can really wrap our minds around, though it's a pretty good analogy. I mean, we can get there on analogy. It takes gravity. So this is the two pieces that I was getting from Michael Elliott's presentation that really stuck with me, is that gravity does the heavy lifting of the computation for us. And so we should be grateful to gravity in that sense of making sense of what would be chaos to us and translating it down. So it's doing the heavy lifting, and it's creating the simplest description of that quantum information then becomes, think of a sculpture. There's a certain experience that we have when we go, I'll say I have, when I go to an art museum. If I'm looking at a sculpture in an art museum, that sculpture is quantum information being translated by gravity to a three-dimensional structure that I can have an experience of. My ability to take that information that's in front of me and take that information that's within me and bind those together has to follow the same process. And so if the process that my consciousness is using is the same process, participates in the same logic and the same power that the universe participates in. I'm sorry, I'm just going to say it. Why should I think I'm anything less than divine? Why should I think that I'm anything less than infinity participating in infinity? And I'm sorry to keep beating up on Donald Hoffman, but I've just done a lot of work with him, so I understand his theory, and it's a window onto these problems. Everything Hoffman's dealing with are finite sets. And indeed, everything everybody else is dealing with at the end of the day is finite sets. They're dealing with basic arithmetic. And arithmetic, there's just not enough stuff, and there's just not enough time to decode 1 second and 1 centimeter of that reality. But here we are flowing through time and binding all this together into a real experience in real time. So we should be very wary of getting away from the three-dimensional classical reality in front of us because we have no hope of decoding the quantum information. We need gravity to do that for us, and it's giving it to us in that simplest explanation. And we shouldn't doubt our own senses and our own ability to participate in that in a way that is true reality if the way we do that is the same process. Therefore, we should be very careful anytime we question reality. Yes, we do want to move away from the hologram itself. We do want to move away from the three-dimensional structure itself and out into the informational structure. But if we go too far, we are going to lose our way because we can't do that decoding. We can't do the processing that gravity's doing for us every second of every day. Therefore, we have to take as absolutely real those forms that we see in front of us, those things. And so, what we have, I believe, within this, of the many ways that it can be applied, is a model and a theory of mental health. If we think we can go too far away from the simplest description that gravity gives us, we will lose our way. Yes, if we just stay with that simplest description, perhaps things will get too bland. Perhaps we won't learn enough. And I'm going to bring one other observation into this, which is that problem of N and NP. So problems that computers could handle in polynomial time, and those problems that we know computers can't handle because the inputs, the variables are too complex. And so the time becomes that would be needed for that processing becomes exponential. Yet, like the Sudoku puzzle, we as human beings can find the answers. How do we do that? That's a huge mystery as well. That's a mystery perhaps on par with the mystery of the binding problem. Computers can't handle NP problems, but we as human beings can handle NP problems. Therefore, we as human beings can't be computers. And I would argue that, sorry, evolution's a non-starter. That's what I've been saying in other videos, is the task evolution would have to solve, which is you and I and consciousness itself, is the NP problem of all NP problems. And so if we know that this category of problems exists that computers can't handle, we know that you can't get there algorithmically, and that's all that evolution would be. It would be a simple statistical algorithm, and it would be woefully incomplete to handle these problems. So I was discussing this with my folks last night, and my mother is a poet, and she recited this poem from memory, and it's what I'll use to end this episode. So this is a poem from the German poet Rainer Maria Rilke. And the translation is, "How surely gravity's law. How surely gravity's law, strong as an ocean current, takes hold of the smallest thing and pulls it toward the heart of the world. Each thing, each stone, blossom, child is held in place. Only we, in our arrogance, push out beyond what we each belong to for some empty freedom. If we surrendered to the earth's intelligence, we could rise up rooted like trees. Instead, we entangle ourselves in knots of our own making and struggle lonely and confused. So, like children, we begin again to learn from the things because they are in God's heart. They have never left him. This is what the things can teach us: to fall, patiently to trust our heaviness. Even a bird has to do that before he can fly. Now, perhaps I should just end on that poem, but I want to point out the use of things. So, like children, we can begin again to learn from the things. This is what the things can teach us: to fall, patiently to trust our heaviness. And this would be my eternal pushback against Donald Hoffman, and just really, you know, uh, anyone who would get us to overly question the reality that we see. We learn from the things. Why do we learn from the things? Because it takes the entire universe to bind that into one thing. And it takes that same process within us to apprehend that one thing. And if those things are composed of quantum information that's so complex, the whole universe couldn't hold the ones and zeros at the Planck length, and we mirror that same process in our cognition of them, I think it's insulting, to say the least, to question their reality.